Alright, here we're trying to find the average atomic mass, and what that essentially means is that this element Q has three types. Some weigh 83, some weigh 84, and some weigh 85. And in a given sample, this is the percent breakdown of each one. So one way you can think of it is if we had 100 of these, we would have roughly 84 would be 83 of 83. So if we add them up, there'd be about 84 of these. There'd be almost zero 84s, and there'd be about 15 or 16 85s. So if we wrote these all out, that's what that would be. So the first question I want to just ask is, what is a reasonable average? If we have mostly 83s and a few 85s, the average is probably going to be somewhere between 83 and 84, maybe like 88.3 or somewhere like that. You want to have an average number in your head because the answer cannot be below 83 and it cannot be above 85. All these atoms have a mass of 83 or 85 or 84. You can't suddenly have an average that's greater than or less than that. So you always want to have a number in your head. Now, what you then do is we calculate what's called a weighted average. And the way we do that is we take the masses, and we're going to assume that an element 83 has a mass of 83. It's not exactly right, but it's pretty close. So these are the masses, and you're going to multiply by these percentages. Now, when you multiply by a percent, you convert it to a decimal first. So 84 is 0.84. You divide by 100. 0.3 is 0.003, and 15.7 is 0.157. If you've done these properly, the decimal should add up to 1. And you're going to multiply each mass by its decimal. So 0.84 times 83, 0.003 times 84, and 0.157 times 85. And you're just going to calculate each of these numbers. So 83 times 0.84, I get 69.72. And 84 times 0.003, I get 0.252. It's not a very good 2. And then 85 times 0.157, I get 13.345. And then all I do is I add these numbers up to get my overall average. So 69.72 plus 0.252 plus 13.345. I'm getting 83.3, and I'm going to round up 32. And that is the average mass of this isotope, which is pretty close to what I guessed. I guess you'll have to trust me that I guessed that. But this answer makes sense. One thing people do is they add up these three numbers, and they're so used to taking an average, they divide by 3. Well, if you divide this number by 3, you're going to get an answer that makes no sense whatsoever. You're going to get something like 26. And you can't have, if all these elements weigh 83, 84, 85, their average can't be 26. So always make sure your average makes sense when you're done. And this does in this case. So that's how you calculate an average atomic mass, provided you know the percent breakdown of each element. So until next time, I am Derek Genova. Have a delightful day.